move on to question number 6. We have a sphere and there are parallel rays of a particular intensity I that are reaching the sphere. The sphere is a spherical black body, so along with this incident radiation, it is also absorbing radiation from the surrounding and it is emitting radiation. Right, and we assume that the energy exchange with surroundings is only through the radiation. What is the final steady state temperature of the black body? So if there was no radiation falling otherwise, then it would absorb as much as it radiates, and the answer would be 300 Kelvin, which is the temperature of the surroundings. But it is absorbing, so there is some extra radiation. So the radiation absorbed will be sigma A into T surrounding to the power 4 plus the radiation due to this I'll just write that in a minute, that will be equal to sigma A T to the power 4, and we want T, right? If there was nothing here, T would be equal to T surrounding, which is 300. Now what will this thing be? So some people might write this thing as I into pi r squared, I into 4 pi r squared. Area total is 4 pi r squared, but actually it will be I into pi r squared. And if you remember, you probably would have done this in physics class, you only take the perpendicular area, right, which is called the area of projection. Right, so this A will be 4 pi r squared, this A will be 4 pi r squared, and this will only be pi r squared, right. So from that we can get sigma into 300 to the power 4 is equal to, we just divide by 4 everywhere, so this is I by 4, 912 by 4, sorry, plus 912 by 4 is equal to sigma T to the power 4. Right, and the value of sigma is given to be 5.7 into 10 to the power minus 8. So from that you can get T to the power 4 is equal to 300 to the power 4 plus 912 by 4 into 5.7 into 10 to the power minus 8. And to be very honest, you don't need to solve it too much because the options are quite far apart, 330, 660, 990 and 1550. And if you solve this, you'll see that the answer comes out to be T is equal to 350. But like I said, you won't need to solve it because you can easily look at this and see whether it's 330 or 630. It would be around 330 if you calculate this thing. Right. So the answer to this is option A. The important thing is in this question is these two are 4 pi r squared, but this is only pi r squared. Otherwise you would get the wrong answer.